So similarly to our power raised to a power rule, today we're going to be taking a look at when we do a power of a product. And a product is already numbers that are being multiplied together. And that batch of numbers is being raised to an exponent. So this says when a product is raised to a power, raised to that exponent, we're going to raise each factor to that exponent. Okay? And I just spelled exponent wrong, sorry. Exponent. All right, so we are going to take each piece inside of the parenthesis and apply that exponent to it, okay? While it looks very robust and, oh my goodness, I can't do this, you so can. If you have your calculator and you can multiply and you can apply these rules, you got this, okay? So let's take a look at what this actually means, all right? So this actually means I have 6x squared all raised to the third power. If I were to write this out, this says I have 6x squared times 6x squared times 6x squared 3 times. Now notice I am allowed to separate the 6 from the x squared. So this is saying I have 3 6's being multiplied together, and I have 3 x squareds being multiplied together. So this raised to the third power has to apply to the 6 as well as the exponent. A lot of times we stop and we only apply it to the 2, and that's where we get the error. We have 3 of those 6's also, all right? So if I were actually simplifying this in my calculator, I would be doing 6 to the third power, so 6 caret 3, and I would get 216. And then I use my rules of an exponent raised to an exponent. I multiply those, so I would get x to the 6. Again, 2, 4, 6. Okay. So when we do this, I kind of like to do what we did with the distributive property and drawing our rainbows. I like to connect our exponent to each of the factors inside. Just like every other video, if you want to try it before I show the answer, make sure you're pausing the video as soon as I'm done reading the question. All right, so let's try this first one. This says AP cubed, and all of that is raised to the 4th. Okay, so let's see what that would be. All right, so this would turn into 4 to the 4th. So that's this first part. And it would be P cubed to the 4th. So I would use my calculator and I would say, okay, well, 4 to the 4th power. Well, that's 256. And P cubed to the 4th, well, that would be P to the 12th. All right, let's try another one. All right, so we have this entire product, -2 m to the 7th, n to the 6th, and that whole thing is raised to the 5th. So what would that be simplified? Well, this would end up being -2 to the 5th, and m to the 7th to the 5th, and n to the 6th to the 5th. And if you need to rewrite each of these factors, please do so. It's going to assist you in how to apply that exponent to each of them. So again, I pick up my handy dandy calculator. If you're going to put -2 in your calculator, please make sure you are wrapping him in parentheses so that negative gets applied correctly. And we are raising it to the 5th power. So we get -32. Here, again, I have an exponent raised to an exponent. So that is m to the 35th. And we have 6 times 5, which is going to be n to the 30th. So although it looks complex, you're just applying each rule separately. All right. One last one for us to take a look at. And so this is actually a two-parter. It's saying I have 2m squared, and that's being multiplied to 3m squared n cubed, which is then getting squared. So this is actually a two-stepper. So let's see if you can do it. And if not, just follow along and we'll see how we do. So if you want to pause it, try it yourself. Let's see what you get. All right. So before we can even start, we have to handle this power to a power, this product to a power. So I'm going to bring this guy down, but we're going to apply this. So my squared, I have 3 squared. 3 times 3 is 9. I have m squared squared, so that would be m to the 4th, because 2 times 2 is 4. And then I have n to the third squared, which would make n to the sixth, because 3 times 2 is 6. And I need to bring down this 2m squared times. So back when we first learned this rule, now we have to look for those same bases. Okay, we got to look for those same bases. So first, I have the same coefficients. I have numbers. So 2 times 9, because this is all being multiplied together, well, that would make 18. And here I have the same base of m. So m squared times n to the fourth. So we have same base multiplication. We keep the base and add the exponents. And then poor little n, he's just by himself, so he comes on down to the party. So this whole strand that was in orange is really what's written in blue. So this one can feel very overwhelming. Even looking at this paper, you're like, oh my goodness, what did I just do? But when you're in it and you break it apart, it makes it a lot easier to see all of the pieces and the parts as they play a role in what we do. So hopefully this helps you get a better understanding of exponents and everything that we are doing with them to combine when we're dealing with a problem.